Hello everyone, and welcome back to part 2 of our Getting Started structural tutorial in Ansys Discovery. In part 1, we went over the import of our geometry, selecting the bodies for physics simulation, applying our materials, and defining our physics boundary conditions. In part 2, we'll be covering the interactions of our bodies, talking about contacts and joints, as well as covering the post-processing of our results and giving you a bit of information on our refined mode. So let's go ahead and dive into part 2. To access our contacts here in Ansys Discovery, in this mode we are specifically in our Explore mode, we can double click on this bonded contacts default over here. And so this is our contact review tool. In Discovery, we are approaching contact from a visual perspective. We find it much easier to be able to identify contacts from a geometric visualization. As you can see in this assembly here, we have a collection of cyan and magenta faces, or simply blue and pink. And what these are complementary contact faces. Additionally, you can see these markers, these individual small white balls, and what they are the individual contact pairs. So when you're working in this contact review tool, you can go ahead and select contacts individually to go ahead and change their type or to edit them, or you can use our geometric filters on our left. As you can see, we have a body and a face filter for our primary selection, as well as for a secondary selection. So if you're looking at a large assembly and trying to identify a contact associated with one body or two bodies, you can use these filters. For example, if I'm looking at the contact between this body here and maybe this secondary body, I can go ahead and identify that contact pair by using my filters on the left side. But for this application, I want to go ahead and utilize a bit of selection of individual contacts. In our Discovery Explorer mode, we have a variety of contact definitions. The first one is going to be a permanently bonded contact. So this can be identified by this symbol here, which is our default contact you can see here on the left side. So this is our default formulation. Bonded contacts you can think of as if they were permanently bonded or fused together. Our second type of contact is to prevent them. This allows the solver to go ahead and remove all relationships from this parts. Effectively, the solver does not know about the relationships, so the parts will pass through each other as if they had no idea that they were there. And our final contact formulation that we have is a sliding no separation contact. So effectively, this is a frictionless relationship between bodies that can move in plane with one another, but they cannot separate from one another. So this is purely a linear contact definition. So for this application, I want to go ahead and set up the frictionless or no separation or a sliding contact on a variety of surfaces, but only on a select few do I want to have a bonded contact definition. Specifically, I want my bonded contact definition associated with the bodies down here at the bottom, consisting of our upright, our spindle, and our bolts. So simply, I'm going to go ahead and use some geometric filtering here. So I want to go ahead and select all contacts associated with the spindle body. So this should be relating to our upright as well as these individual bolts. So from here, I can simply say I want to convert these contacts to be permanently bonded. So they will be removed from our contact review tool, as you can see here. And we have 13 remaining contacts that are available in our contact review tool. That group of contacts that we removed that was associated with our spindle can now be seen over here in this bonded contact group 1. As you can see, we have an activation and suppression object over here. So depending on what you need for your assembly, you can turn these on and off. Now for the remaining 3 contacts, which are the ones associated with the bolts, I'm just going to go ahead and manually select them. And you can go ahead and convert them all at a time, holding Control to select multiple, and you can see the plus sign is there. And we'll just go ahead and do those 2 to a group. Or if you want to go ahead and select an individual contact, you can convert that one as well. So as you can see, we have these 3 contact groups down here, and they're associated under this bonded contact group, but I have this individual contact pair. If you have an individual contact pair, this allows you to edit the individual faces here. As you can see, I have a primary selection, which is indicated by the orange, and a secondary selection that is shown by the blue. So these are on opposite faces, or meaning that they are going to be on different bodies, and this is the relationship between the faces. If you wish to edit these, you can use a combination of holding Control to add to the primary. If you want to add to the secondary or to remove to the secondary, you can use this secondary selection filter here. But for this one, let's just leave it as default. Now let's go ahead and go back to our bonded contacts, our contact review tool here. As you can see, this is relating to the remaining components of our assembly. And in this situation, we want to as accurately represent the kinematics of this application as possible. So for these remaining contacts, I want to convert them to be a sliding contact, meaning that we're going to get relative motion in plane with all of these surfaces to one another. Granted, these are all going to be relating to the individual contact pairs and not collectively as a group, but we can convert them all at the same time. And we can even just change this rather than converting them with this object here on the right. As you can see, we can convert it to a sliding contact, a joint, a bonded contact, or prevent them. You can simply just change the classification of your default contact, which is in this case in our contact review tool. So to do so, simply click this object here, so this double arrow, which exposes a bit more options for our contacts, including grouping, the detection distance, which is how we review all of the potential contacts based on their geometric orientation with one another. But if you wish to change the classification or the type, you can click this again to go ahead and be able to choose our default behavior. So as you can see here, it's bonded. We can select this drop down and choose sliding. So at this point, you can see that we have idealized and frictional grayed out. Idealized is our word in Discovery for a no separation, frictionless contact. Now, if you wanted to go ahead and access this in the refine mode, if I go ahead and click into refine, you'll notice that I have the opportunity to uncheck idealize and add in frictional. And this is because we're using the mechanical MAPDL solver in the refine mode, which has some more advanced contact definitions. But for this application, we're just going to be reviewing most of our simulation setup in the Explore mode. So let's navigate back. So in this situation, we'll leave it as a sliding contact. So to get out of our heads-up display, let's hit escape a few times. And at this point, we're ready to solve our simulation. So let's go ahead and navigate to the bottom right corner of our screen to our results arc, where you'll see this solve button. And at this time, we can go ahead and click play. So now we're beginning to see some results here, and this is due to the power of our live GPU solver technology. We're able to get results in only a matter of a few seconds here. What you can see, what we're rendering here is a contour relating to the displacement of this simulation. You can see this variable is displayed at the top of our legend here, and you can see the relative values of our displacement. Additionally, you can see that we have the ability to change the unit system for our display. So this doesn't change the default unit system because we're locked to metric at this point. But if you wish to see your results in another unit system, maybe in this case you want to see your displacement with respect to inches, you can go ahead and change it in that manner. In this case, let's go ahead and change to millimeters. So when you're on your displacement display here, you'll also notice we have the ability to look at our deformation. So you can go ahead and animate the shape. So this icon here, by clicking it once, indicates we're looking at an exaggerated or scaled deformation. So this is going to be a bit more extreme than you would actually visualize in your application, but it's really good for looking at the bulk movement. Additionally, you can click it one more time to get back to the true deformation, but we're going to hold off on doing that because we want to look at the animation. So to play the animation of the displacement, let's simply go ahead and click this object here. So let's go ahead and look down our x-axis to review our interaction between all of our bodies. And you can clearly see that they are sliding relative to one another, and we're getting a good representation of the kinematics of a bottomed out suspension. So in this situation, let's go ahead and review a few more post-processing objects. So in this case, we're looking at our true deformation. At this point, you can see the animation is much smaller, but to turn off our displacement rendering here for our true deformation, let's go ahead and click this object one more time. Now to go ahead and change our variable that we're displaying, you can navigate over to our legend and select these three dots here. This displays our other variables that you can possibly render. So in this case, we can go ahead and take a look at von Mises stress, or the equivalent stress in this model, and we can see where a lot of the load is being carried locally within these parts. Additionally, if you can go ahead and identify the maximum and minimum areas, or the highest and lowest values, by clicking this cogwheel and selecting this icon here. So this will identify the maximum and minimum stress locations in your application. This can be used for a variety of other variables as well, not just stress. So let's go ahead and turn those objects off. Additionally, you can change the values of your legend, or the scale of it, by simply clicking and dragging. As you can see, I'm reducing the peak value of the legend, or you can go ahead and type in your own specified value if you want. So maybe in this case, I want to do 1e to the 8th, and I can set it to my maximum value. Maybe this is a good idea. Maybe you want to go ahead and consider this because we're using a linear elastic material definition here in Discovery. So you could set this at your potential yield value, or maybe a little bit lower, to basically identify if any of your areas are going to go into plasticity. But for this situation, we can go ahead and reset our legend by clicking the cogwheel and clicking reset at this point. So not only can you process from a visual perspective in Discovery, you can also create monitors to get specific quantitative results out of it. So you can navigate up to the top right corner of your screen, and you can see we have this charts icon. If you click it, it exposes some monitor values. So based on the types of physics you're solving, in this case structural, we'll provide you with a small subset of default monitors. In this case, we have your max stress and displacement, as well as a factor of safety. But you're also able to go ahead and create your own variables here, or monitors as well. So to do so, you can navigate up here to the top onto our ribbon on our simulation tab. You can click this monitors icon. You can click the drop down if you wish to choose other ones, or you can simply choose custom. So knowing that we have some peak stress down here on this bottom face, maybe what I want to do is select just this face down here, and we want to apply a maximum review from von Mises stress. So you can choose the variable you wish to calculate and specify a singular face, or you can go ahead and select the face and apply the variable you wish to. So in this case, maybe I can go ahead and select this bottom face to create a monitor with respect to those faces. While I'm in my max von Mises stress, I can go ahead and maybe identify another area, maybe where I want to keep track of stress, and put a monitor on those faces as well. As you can see, we don't have any values populated in these monitors, and that's due to the fact that we created them after our physics solution. So if you wish to quickly update these, you can restart your simulation to have it repopulate your values by clicking this restart arrow here. But it's a good idea just to go ahead and create these before you click run on your simulation. So as you can see up here on the top right of our screen, we have these charts, and you wish to display them. You can go ahead and click here and then choose to see your current design point. So this is a singular design point. So if you change the value of one of your variables, this could be related to a geometrical change, changing the shape of the object, could be changing materials, changing boundary condition. Any change to this environment will create a new design point. So just to demonstrate this, I'm just going to go ahead and change from 1,000 pounds to, let's just go ahead and make it 1,200 pounds. So as soon as I change that value by clicking in this window over here, you'll notice our simulation information display has our solving icon going all the way around. It kind of looks like a caterpillar. So it's currently calculating our new simulation. And so our color contours here are going to update on our body first, and then our charts will update here on our monitors. And as you can see, by ramping up my load, we had a decrease in factor of safety, an increase in our displacement and stress as well. Things we would expect. So we've covered the basics of looking at a bit of our post-processing here. One of the few things I wanted to go ahead and cover right before we wrap up part 2 is relating to our refine mode. So let's go ahead and hop into our refine mode, which uses our high fidelity Ansys mechanical solver. So let's click this button down here to go to refine mode. As you can see, everything that I set up in my explore mode is going to transfer over to my refine mode. So this is a great way to ramp up the complexity of your simulation without losing any of your previous work. So in these situations, you will have a bit more control over the simulation especially relating to contacts and specifically the mesh. In Ansys Discovery, we have our Explore mode and our Refine mode, which can be used in a variety of different ways, where the Refine is going to be a bit more traditional simulation. So as you can see up here in the top in our Refine mode, we now have access to our global and local sizing controls because we are using Ansys Workbench meshing in the background. And if I access some of my contact groups, you'll notice if I select this individual contact, I still have the same controls here. But if I select a group, you'll notice that I can go ahead and have a bit more options. So I have the ability to go ahead and uncheck idealize, which means I will allow separation to get a full nonlinear contact if I would like, rather than just the linear idealized frictionless no separation contact that's available in Explore. So we hope that this was helpful, and thank you for watching part 2 of our Getting Started structural tutorial for Ansys Discovery. And thank you, and take care.